Assalamu alaikum warahmatullah. Good morning. Today's class actually is going to continue yesterday's class. Yesterday we started the database design. We continued the database design and we started to learn how to transform from entity relationship into relation, which means table here. Okay, today we are going to continue yesterday's slides. We have stopped here yesterday. So here is the step number 4. Yesterday we have learned 3 steps. We will go through quickly to make a quick recap. This is step number 1, which is to map the regular entities to tables. How to map the regular entities into a table, how to convert it into a table. So things here is to map the simple attributes, to avoid to map the composite attribute, and to use only the subcomponents of the composite attribute, and also how to create a table for the multi-value attribute, table with the relation and so on. Then we have step number 2 is how to mapping the weak entities and how to create their relations. And after that, step number 3, which is mapping binary relationships. So binary relationships are between the relationships that's between conducted between 2 tables. So it could be one to many, many to many, or one to one. So yesterday we learned all of these 3 types of binary relation. For today, we are going to learn how to map the associative entities. Associative entities. Okay, for associative entities, we have actually 2 types of associative entities. The first type that has no natural identifier. If the associative entity has no natural identifier, then the default primary key for the associative relation is composed of the primary keys of the 2 entities. Okay, so here in this slide, as you can see here, we have a customer and vendor. Okay, so if the shipment here at the middle is an associative entity, but the shipment here has an ID, has a shipment number, right? So this one has a natural ID, and its ID is the shipment number. It's not the vendor ID combined with the customer ID, because the shipment here has a shipment number. So this is the second type here. The second type, which has identifier assigned. So it's natural and familiar to end users. So the shipment ID is natural. Okay, default identifier may not be unique. This is quite confusing. Just skip this point. I'm not going to go that deep in here. Just I want you to learn this. So if the associative entity has an ID, has an natural ID, then the ID will be that field, will be the shipment number, not the vendor ID combined with the customer ID. But in many cases, when we talk about the associative, like here yesterday we talked about the what they call it, the raw material and the vendor. Then here we have code. So here the primary key of this is the material ID and the vendor ID, which is the combination of both primary key from the other tables. Okay, so this is how it is different. This is the first type of the associative entity. So here we have no natural ID for the code. That's why the ID is going to combine the two foreign keys that comes from the superior tables. Okay, is that clear, guys? Is this clear?
Yes.
Yes.
Yes, yeah.
Okay, so here that's all about the associative. This is the first example of the customer, vendor, and shipment. Then this one actually is the cruise port model and how we transform it into relations. So the first customer, the first entity has customer ID and name, as you can see here, customer ID and name, and maybe other attributes. Then here we have vendor, vendor ID and address. So vendor ID and address and maybe other attributes. Then here we have the shipment that should have the vendor ID saved here and the customer ID is saved here together with the three attributes, which is the shipment number, amount, and date. So here we can see shipment number, amount, and date, and this is the customer ID coming from the superior table and also the vendor ID coming from the other superior table. Okay, so can you tell me here which one is a strong entity and which one is a weak entity?
Customer. Strong.
Customer is what? Weak or strong?
Customer is strong.
Okay, what's about the vendor?
Maybe it's weak.
Vendor.
Vendor.
No, vendor is strong also. Vendor is strong. Okay, I will give you.
Shipment is weak.
I will give you another property that you can rely on to differentiate between the strong and the weak. If the table has no foreign key, that means it's strong. And this one is the level 0. Tables that has no foreign key is level 0, which is the highest level of tables, which is the strongest table, strongest type of tables. Okay, clear?
Clear.
Yeah. So customer and vendor here are strong. Both of them are strong. That's why we call them superior. Then here the shipment table is weak. Why? Because the shipment table cannot contain any data unless we have a data in the customer and data in the vendor. Otherwise, we cannot key in any kind of data here. Okay? Okay. Step number 5. Step number 5 actually is the transforming of the entity relationship. Is the mapping unary relations. The mapping of unary relations. Unary relations actually is the relation conducted between the table and itself. So here, this relation, it could be one-to-one, one-to-many, or many to many also could be. Okay, depends on the scenario. Here, let us, before I discuss all of this here, let us go to the scenario here, the example. Okay, in this example, we have an employee table, employee entity, and the employee entity includes the data of employees and also data of their bosses or their managers, because their bosses or managers are also employees in the organization. So here, every field here, every record should have, if let's say we have Ali, maybe the employee ID is 10, the name is Ali, the birthday is whatever, then the manager ID is the ID of, for example, Hassan, which is 100, for example. So that means Ali is managed by Hassan. Okay, actually I explained this before, right? I give you this example before. Last week, if I'm not mistaken. We have taken this example. Anyway, in this case here, this one is the primary key, the employee ID is the primary key, and the manager ID is a foreign key here. So this table actually is creating a relation of one to many in this case. So one employee could lead, you take care about the every word we say or we mention or the customer say. So the employee could manage multiple employees. Okay, so as you can see here, the relation is mandatory one and the other side is optional many. Why? Because some employees are not managers, or not some, most of the employees are not managers, but some of them are managers. So every manager of them will manage a group of employees. Okay. So what's about the top managers? The top manager who has no boss. The top manager who has no boss, the manager ID of him or her will be empty, will be null. Okay. Is this clear, guys? Is it clear?
Yes, sir.
Okay.
Okay, so let us go back to the slide here. For mapping unary relations, we have one to many recursive foreign key in the same relation. So one to many here, or the unary relation, they call it recursive. Why recursive? Because the table is calling itself. Okay, then we have many to many, which is two relations. One for the entity type and one for the associative relation, in which the primary key has two attributes, both taken from the primary key of the entity. Okay, this one many-to-many scenario is somehow complicated. Okay, we have one basic rule for the many-to-many. I think most of you knows that rule. The many-to-many relation cannot be conducted directly. It's supposed to be conducted through what? Can you tell me through what?
Relationship.
Yes, I know. When we conduct many-to-many relation between two tables, what we have to do?
Another table between it.
Yes, we have to put an intermediate table, middle table, right? So here also for the unary relation, like this, I am going to show you to the paint. Here, if this is two tables having a many-to-many relation, we have to put one at the middle, right? One table at the middle. Okay, this is the case. So what if this table and this table are the same? So in this case, the table, we have one table that has like this relationship, many-to-many relationship. So we have to put something at the middle, right? So the same table should be connected through two links to another table. So every link should represent something. Okay, here let us go to the scenario directly here. In this scenario, we have something called the relation between the item and its content. Because in many cases, especially if, let's say, for example, we have a factory, for example, then that factory manufactures some items, and that items includes other items that's already in stock. Okay, for example, I want to take a very simple scenario. What is the example? If let's say I would take other scenario, even this scenario is even compatible with the supermarkets as well. So it could happen in the supermarket. If let's say we have something called yogurt, and we have milk. Okay, so this one is an item, right? And this one another item. So suppose that the yogurt ID is 100 and the milk ID is 200. So what if we want to create one package that includes one bag of milk and 1 cup of yogurt together. So maybe this one is 2 ringgit and this one is 6 ringgit. So we want to combine them together and we want to sell them for 7.5, for example. So this component, this item will become, for example, 300, the ID, and the price will become 7.5, like this. Okay, is that clear, guys?
Yes, sir.
Yeah.
Yes.
So in this case, this item includes 2 items that's already saved inside the database. Okay, so based on this, let us now create a table here, and let us put the ID, name, this one, items, and also price. Okay, so here what do we have here is, okay, let us go to the top. We have item 100, the price is 2. Item 100, yogurt, price is 2. Item 200, milk, price is 6. Item 300 is, for example, is a promotion whatever, and the price is 7.5. Okay, so here in this case we should have another table here. We should have another table based on the slide. Also, you can see the slide here. The item has item name and the cost. Then it contains quantity. Contains a quantity of other items. Okay, so here we can see that the item components table should include the item number here, and because it will have to have the item number of the for example, for the promotion package, it will be 300. Then inside the 300 we have the component number 100, the quantity is 1 piece, and again 300, the component number 200, and the quantity is 1 piece. Okay, so I'm going to explain this to you. So here, components. Okay, so maybe we need to make it wider here. Item ID, and here component ID, then here quantity. Okay, so for the case that we have drawn here, we have component number 300, right? So this component 300, which a combination of multiple items, so it includes the component number 100, it includes one piece, and also this 300 includes the one piece of the 200, one piece. Okay, like this. Is that clear, guys?
Yes.
So maybe we want to create another package that includes 2 pieces of yogurt and 2 pieces of milk, and we want to call it 400, and the price is 14. Okay, so in this case we should have another entry here, 400, the name is whatever, the price is 14 here. The details of this component is like this. The item 400 contains the item number 100, but the quantity is 2. This one has 2 yogurt and 2 milk, right? So also here again 400 includes the milk, 2 bags of milk. Okay, is that clear, guys?
Yes.
Yes.
You see, this is a practical scenarios that could happen even in mini-mart. Okay, in the big factories, they bring the raw material and they save it in their item table. Then after that, they take some portions of that material, that raw material. They take some portions of maybe 2-3 types of raw materials. They combine them together to create another item, right? So in that case, we have to have the components item, or maybe the formula table, what they call it, formula table. So based on the formula table, we can know the components of every item. Okay. So that's all about this. As you can see here, we have 2 types of relations here between the table and another table. So let us draw it. Let us draw this. Okay, this is the item table. So we have item ID here, items, item ID, and we have what they call it, name and price or cost. Whatever, the price is not the cost, actually 2 things are totally different, but in the scenario they use cost, no problem. And here we have the other table. The other table have the item ID, we make it IID, and the component ID, then the quantity. Okay, so this one here is a primary key, right? And here, what is the primary key here in this table? In this case, what is the primary key?
Item ID.
Close your mic, please. It's a lot of noise. Yeah.
Item ID.
The item ID cannot be a primary key. Why? For one reason. Because here in the components, the item ID could be repeated. And also the component ID could be repeated here. You see? So it could be repeated. So it's not unique. Here, because the components table doesn't have a natural ID, so the primary key supposed to be both of this together. Okay, so these two are primary key, and this one is a foreign key from here. Means because this side is a primary key, so this one will be 1, and this side will be many, and this one is mandatory, this one could be optional, because not all items has components. Some items doesn't have components, it's only one item itself. Okay, the other field also, this one is also a foreign key. Okay, this foreign key is also coming from the other side, from the primary key of the other side. So this one is mandatory 1, and here this one is optional. Why we make the two sides optional? Because it's optional for the component to have, for the item to have components, and also it's optional for the item to be a component for another item. Okay, so that's why the relation is now many to many, and this relation is considered unary, even though this relation is involving two tables. Okay, this is very important, keep it in mind. This one, if in the assignment or in the exam they bring you this kind of design, and they ask you what kind of relation is this, this relation is unary. Okay, many to many and unary. Okay, why unary? Because this one involves only one table at the two ends of the many to many relation. Okay, is that clear, guys?
Yes, yes.
Okay, fortunately. Okay, then we move on, and here we have another thing called mapping ternary, or what they call it, in dash array relationship. So ternary relationship means the relationship that deals with multiple tables more than two. That deals with tables more than two tables. Okay, here one relation for each entity and one for the associative entity. Then associative entity has a foreign keys to each entity in the relation. Okay, let us move directly to the example here. Here in this case, how many tables do we have? We have the patient, we have this is the patient table entity, and the physician entity, and also we have the treatment entity. Then here we have the patient treatment. Patient treatment involves the three tables. So here we have three relations in total, one relation for every entity, one relation for each entity. Okay, so one for the patient together with the associative entity, another relation for the physician with the associative, and also the treatment, one more for the treatment and the associate. Okay, so let us go, remember this, keep this in mind, and go here. Okay, or maybe I need to copy this here in this slide to keep it easy to remember. Okay, here, as you can see here, this is the long table here is the associative entity. So as you can see here, we have a foreign key from each superior table. From each superior table, we should include the patient ID as a foreign key, and also we should include the physician as a foreign key. We should include the treatment code as a foreign key as well. Then we have the date and the time exactly here based on this diagram, date and time and results. Okay, all of this based on this example here, based on the slide, they take these five fields, which is the patient, physician, treatment, date, time. They put them together as a primary key. But this is really not a good practice. This is not a really good practice because we never do this in the real practice. Okay, so date and time actually could be involved in the primary key, but really it's not good. Why? Because the treatment normally it has a natural ID. It has a natural ID, which is the what they call it, the prescription ID or prescription number. So the prescription number is supposed to be involved here as a primary key, and the patient ID will remain only foreign key. Physician ID will remain only as a foreign key. The treatment code also will remain as a foreign key. Then this date, time, and results will become normal attributes. Okay, is it clear? Is it clear or not?
Yes.
Clear. So
Clear.
here they wrote a comment here. Remember that the primary key must be unique. So the prescription ID or the prescription number is unique, naturally unique. So that's why we shouldn't need to include all of these fields in to form the composite primary key. It's actually a complicated design. That's why we shouldn't make it this way. Okay, for the purpose of this course, okay, we can take it as it is. If it comes to the exam, we can make it like that. But if for the real practice or for the best practice, we never do this, as I explained. Okay, then we move to step number 7, mapping sober type subtype relationship. Sober type and subtype is what they call it, the relation between the how can I say? Okay, let us go through it. For example, like this, you can see here employee. Then after that, what do we have? We have the hourly employee, we have the salaried employee, and also the consultant. This is actually the kind of the scenario of inheritance. If you talk about the object-oriented programming, then we will talk about the inheritance. So how we implement the inheritance, I already explained yesterday and also the last week. But anyway, we are going to go through these slides, and I'm going to explain to you, inshallah. So here, mapping the sober type and subtype relationship. Here we have one relation for sober type and for each subtype, as you can see here. One relation between the sober type. The sober type here is the employee. So one relation between the employee and every other subtype of employees. Okay, so we have subtype as a consultant, we have subtype as a salaried employee, and we have subtype which is the hourly employee. So the salaried employee is the normal employee, the common one. And the other one is what they call it seasonal or maybe hourly, whatever. Then the consultant has another thing because it should be based on a contract, and we should have the contract number and the billing rate and everything. This one is going to have what they call it hourly rate. But the normal employee will have an annual salary, and we have also stock options. I don't know what is this. Anyway, what is this? Slide number. Okay. So here we the first thing, we have one relation for each subtype with the sober type. Okay, sober type attributes including identifier and subtype discriminator go into sober type relation. Again, sober type attributes including identifier and subtype discriminator go into sober type relation. Okay, let us later see how it looks like. Subtype attributes go into each subtype. Primary key of sober type relation also become primary key of subtype relation. So here the primary key of the sub table will be exactly the same. The employee number will be the primary key, and again this will be complicated. So the primary key will be the foreign key at the same time, exactly as I explained yesterday or the week before. Okay, so here actually the text is a little bit confusing. When you read the text, you confuse what does this means. But anyway, after I explain, you will understand all of that. So one-to-one relationship established between sober type and each subtype with sober type as a primary key, as a primary table. Yeah, definitely like that. Okay, let us continue here. I will take this also, copy it, put it here to allow you remember what is the scenario. Okay. Okay. Here, this is the sober type, which is the employee. Employee here has an employee number, and employee name, address, employee type, date hired. Okay, so here the 5 attributes, including the employee number, which is the primary key. Also here, the hourly, for the hourly employee, it has only an hourly rate. So the hourly rate attribute and the employee number will form together the hourly employee type or table. And here the hourly employee number actually is the primary key of this table, and also is a foreign key that's linked to the primary key of the sober type. So this field at the same time is a primary key and foreign key at the same time. So the relation between this and this is 1-to-1 here. And the relation between the sober type here and the second salaried employee is also 1-to-1. So this table of the hourly employee is an extension to the employee, and also the salaried employee is another extension to the employee table, and also the consultant is another or third extension to the employee. Okay, so also here the salary employee number is a primary key and a foreign key from the employee number of the sober type. Also the consultant here, the C employee number is a primary key and foreign key from the employee number of the sober type as well. Okay, is that clear?
Yeah.
Yeah, you in this course you are going to learn many real scenarios, many practical scenarios that open your mind for the market. Really, it will prepare you really for the market. So you understand about this case, this scenario, that scenario, the how to create promotion package, how to create maybe discount for something or whatever. Very practical, real scenarios. Okay, so please keep them in mind and always try to think about the other scenarios that happen in the real life, and try to think about how does their design looks like. Okay, always when you go to mini market, to supermarket, you see some scenario, you try to think it how they designed this. or how the design of their database looks like. Try to think about it. Okay, then here we come to the end. We have a number of exercises. So the first exercise is this. We have number, then multiple of another thing. So here the number could be even or odd. Then the number should have sign, and the number also has a value, right? Then here we have multiple of, then we have the ratio. So every number actually is a multiple of another number with a certain ratio, right? So could we make this? Oh, this is the exercise number 2. Exercise number 1, let us come back, or maybe we finish this first. Okay, no problem. We finish this first. Do you want to finish this first?
Okay, can.
Yeah, the relation here of this scenario is what?
Many to 1.
Many to 1 is wrong. Why? Because you see here the cardinality of the two sides is many, right? So it's many to many, but it's a unary relation. So it will have the table of numbers and involving another middle table to form the many to many relation. Okay, I am going to explain this exactly similar to this here. Exactly. Okay. We would take the table of numbers. So here we have, where is it? We have even, odd, sign, and value. So we take the value because the value is unique. Value, it will be the primary key, and here we have what they call it, sign. Oh, opposite way, sign. Then we have even or odd. The column name shouldn't have special characters like slash, or it couldn't be an option like this. So maybe we make this only the name, we make it even, then we make it true or false. So if the value is true, that means the value is even. If not true, that means it's odd. Okay. But for the purpose of explaining this scenario, I'm going to keep it as it is. Then here we have multiple of, then the ratio. So here we need to create another table. We call it multiplication table. Then here we have the value. Okay, then another value, multiple, and ratio. Sorry, writing on the screen is very hard. That's why I'm using my finger to write. It's not easy to write. Okay, here, this value is a foreign key and a part of the primary key, and multiple is also a foreign key and a part of the primary key. So here this one is related to the, or connected using one relation to the primary key of the super type, and also this one is like that. So here, and this one is like that. This one is mandatory because or maybe optional, because some numbers has no every number has multiplication, so this is mandatory. Okay. Okay, so if let's say number, the value of 10, value of 10, the sign is, for example, positive and it's even. Okay, here the value of 10 will have the multiplications. So so maybe the multiplication is 2, sorry, 20, and the ratio is what they call it, 10 over 20. The ratio is going to be 0.5 here. So the 10 could, the multiplications of 10, one of them is 20, right? So if we take 10 times 2, it will become 20. So it's, the ratio actually is wrong. It is not half, it's 2, because 2 times 10 it will give 20. And also 10 here, 30 and 3. 10 here, and the multiplication is 5. If 5 here, it will become 0.5, because 0.5 times 10, it will give us 5. Right? So this is how it works. Okay? Is that clear?
Okay, clear.
Yeah. So these two are the primary key, to ensure that we never repeat the same multiplication value. Okay, we go to the exercise number 1. Exercise number 1 is also unary relation, which is 1-to-1. Okay, this one is a solider who has what they call it, superior commander. Okay, so maybe the commander is also saved in the solid soldier, right? Yeah, soldier. The soldier and the highest level of soldiers is saved in the same table, so that's why the relation will become unary, and it will look like this. So here we have the soldier, and the table is like this. Then this one is like the employee and manager. It's the same thing. Soldier ID, then maybe name, maybe whatever. Then after that, the commander. The commander is the superior soldier who controls or what they call it, commands the soldier itself. So maybe soldier number 10, his name is Ali, and this one other information, and this is null. Null means has no commander. It's maybe this soldier is the highest level, has no boss. Okay, then after this, maybe soldier 20, maybe his name is Ahmed, then his commander is number 2. Okay, so this field actually is a foreign key coming from the primary key. This one is the primary key. So the relation here is 1 and here is many, but this one is optional, because not everyone is a commander, or not everyone has a boss. Okay, so this relation is optional. you're supposed to make these exercises, but I just explained to you this two. Then we see how you do exercise for this. Okay, no, this one is not practical scenario. That's why I'm not going to give it to you. Then the exercise here, student takes course. Okay, this one, exercise number 4. Exercise number 4, actually, I want you to make it as an assignment that will be counted for your assessment. Okay, this one is a little bit complicated. I'm not going to trouble you. So here we have farm animal, farmer, pasture land. Just forget about this, and let us see 6. Create game developer. Also, this one is confusing because I don't want to give you examples that you cannot link to the real life. I want to give you something that's really easy to understand. Okay, and here we have this one, library book patron. Okay, so we take only the exercise number 4, and based on this I need you to draw the entity relationship. Then the entity relationship is here, no need to write it. I need you to transform this entity relationship to tables. Okay, guys.
Okay.
Okay.
Yes.
Just like the table you draw for the example, right?
Yes. When
Okay.
when we have the entity relationship diagram like now, the second step is to transform this entity relationship into tables, right? So I need you to make the tables and to create the relations and to show me what field is the primary key, what field is the foreign key, and the cardinality of the relation supposed to be clear also. And here for this one actually the diagram is not correct here. The diagram has something missed. Okay, because here once the relation has an attribute, it's supposed to be an associative relation, right? So
Correct.
if associative relation, then the shape supposed to be square and diamond. Then after that you have to think, this takes, what's the meaning of takes? It's enrollment, right?
Register, yes.
Yeah, enrollment or register or whatever. Then is it naturally does it naturally has an ID? Just think about it. If the enrollment of every course has an ID, then you need to think about it. If it naturally doesn't have an ID, then you need to think how to make it. Okay, so based on the reality, I need you to design the best design, or the best design you can make. Okay, don't forget to highlight the primary key, the foreign key, also the cardinality is supposed to be complete. You cannot make one and you don't tell me is it mandatory or optional. You have to tell. You must tell mandatory or optional. If you don't tell, then marks will be cut. Okay, so for this exercise I'm going to calculate it for your final assessment for the what they call it, for the week 1 to week 7. Okay, so please take it seriously and make it properly. Then you can go here. Also, you can go to the entity relationship diagram, entityrelationshipplus.com, and you can create your design. Then you can share it with me. Okay, you can export the image, you can whatever, you can save it, then send it to me. I can plug it into my account. It's up to you. Okay?
Okay.
Yeah. So before the next class, inshallah, I need it ready. I need it to be ready. Okay? And that's all. That's all for today. If you don't have any question, I'm going to close. I'm going to finish this class. Any question? Okay, so don't forget exercise number 4. Don't forget it. If you have any issue, if you need if you have any question you want to inquire about anything, you just let me know through the WhatsApp group, then we can discuss. Okay? Thank you very much for attending my class, and inshallah see you next week. Okay? Assalamu alaikum wa rahmatullah.
Thank you, Doctor. Salam.
Waalaikumsalam, Dokter.